Hello. So this is a worked solution for one of the workshop questions that we were given in week two. At the time, we just started learning about number states, and I remember finding this question quite difficult. Looking back over it, it's, I think, reasonably simple, but that means it's a good refresher, and that hopefully you can find any mistakes that I may have made. I also said in the forum that I was going to do this in two different types of notation, but I ended up just doing it in number states. Look forward to your feedback. Okay, so our question is a pretty standard one. It's show that this thing equals this thing. Now, since we haven't done the rest of the question, I should probably point out that these operators here are on the position basis, and we've also been given that we're in a state where n particles are all in the same single particle state, which is given by this here. All right, so now that we've got the background information, let's work on the problem on the left and write down useful information on the right. First bit of our information that's probably useful is to know what our state actually is. So we can represent it in the number state nice and easily as, and we can shorthand this as, now that we know that, we can start working out what this expectation value is. But now, these operators that we have here are in the position basis. So we can't apply these operators to our number states. Instead, we're going to have to represent these operators in terms of the number state operators. So we know that the creation operator in one basis can be written as the sum of creation operators in another basis, where this coefficient value is, now we know that this R is in the position basis, and we can expand our single particle state in the position basis using what we were given over here, where we've taken the complex conjugate of our single particle state. Now we can see that this here is a delta function. Putting that in and evaluating it gives, so this means our operator in its full form is, of course we can work out what the annihilation operator is too by taking the complex conjugate of this. Now that we've got these two new values, we can plug them back in over on the left side, replacing this and this. These sum values can be pulled out, and this are just numbers, so they can also be pulled out. This gives, as we evaluate our sum over j, when j equals 1, we'll apply to this state, and we'll pull out a 0. It'll do that for all states except for the pth state, as that state has an n in it. Similarly, this will happen as we do the sum over k. So this is essentially two delta functions. Evaluating these deltas, where now we can see this combination of the creation and annihilation operator is just the number operator for the pth state, which will pull out a value n. And this, of course, is just 1, giving as required.